Hi, folks. Guess what? We're having another talk that deals with anonymous networking. How did that happen? Our speaker is Kevin Froman. He's a computer science college student. He came all the way from St. Louis, Missouri, the show me state. He has an interest in security and ethical technology. He's experienced in web development and security, and he has a fondness for cryptology and decentralization. Let's hear it for decentralization.
Cryptography.
Oh, sorry.
All right. So, as she said, my name is Kevin, and I'll be talking about improving anonymous networking, and so this ever since I was about like 13, I discovered Tor, and I initially just used it to play on games at school and stuff, and that just felt so freeing to me to be able to anonymously, relatively anonymously use the internet and circumvent censorship. And ever since then, I've been playing with and researching on various other networks, such as but not limited to Tor, I2P, Freenet, ZeroNet, and many others. I've been, and I also have like a strong infosec interest, so there's been a good bit of security research that I've done into it. And I personally believe that the term Darknet is appropriate to describe these networks, but it's been kind of ruined by media, like negative media attention. So I believe that Darknets can benefit everybody, especially marginalized people or people that are at risk, such as journalists and LGBT people. So the main goal of a Darknet is to maximize privacy. And to me, that there's like three main things that are involved in maximizing privacy in a Darknet, and that's obviously hiding message content. The time of communication is sometimes necessary. Not all networks take that into account though, and participating party lists. So like who's involved in the communication. And that image right there really demonstrates how I think surveillance feels, especially mass surveillance. It constantly feels like somebody is looking in through the bathroom stall at you. So I'm kind of assuming that most people here have used Tor at least once, and as you would know, it's just a browser. So other than anonymously routing things, everything is basically the same as a normal browser, a little more secure though. So I think we need more of a stack or kind of a platform to host anonymous stuff on, because the way people tend to host it now is kind of terrible, honestly. A lot of hidden services are brought down simply through issues with the stack. Also, Tor is just a routing mechanism, so it doesn't have any way to really store information, unlike other networks such as Freenet. So I think we need a mechanism to store things as well. So what would make a good anonymous platform? Well, there's two really broad categories: security, usability, and scalability. The most important part of security, though, is metadata minimization. So that includes who's communicating, when, how big the communication is. And real quick, I believe that decentralization is important, but not just in the technical sense. I believe it's important in the social sense as well. So it's important for there to not be any points of failure in a network or in a community or even in a project. So it wouldn't make sense if you just if some authoritarian government were to just arrest a couple of people and then the whole network were to go down. That wouldn't actually be decentralized. A good example of that is DNS. So it's not decentralized in a social sense. And I just want to explain the different types of latency and their pros and cons in anonymous networks. High latency leads to bad user experience in a network, but it really does improve privacy quite a bit because it's typically used when you're mixing a lot of traffic together. So it prevents correlation attacks, or at least makes them much more difficult. Low latency is basically how Tor and I2P work. It's best for web browsing and other things that need to be really fast. Some examples of like high latency networks are like BitMessage, sort of, Freenet, and like mail mixers. Although BitMessage and Freenet are more so storage networks, sort of, so it's not really exactly appropriate to call them high latency. It's really just a rule of thumb. So not everybody like needs like 100% security or privacy. Like it wouldn't make sense if everything took like 5 hours to work. So we do want to be able to do some things fast. So it's really dependent on like your threat model and exactly what you're doing at any given time. And for distributed storage, which again, like Tor and I2P lack, it has a lot of benefits. It can be used as a sort of broadcast type communication. So that has a good deal of benefits because you can't easily tell who is communicating with who. It's high latency, like I said. It has censorship resistance, so if you're storing data across multiple machines, it prevents any single point of failure, like unlike a Tor hidden service, which will typically just have like one server. If you're using something like a messaging system, you don't need always online, so your friend could be offline to send them, and you'd still be able to send them a message for them to receive later. And in my research on a lot of existing networks, I found that they have like strong web components involved, like built-in web servers. And I discovered that you could use someone's browser and like embed JavaScript. Like an attacker could embed JavaScript on a site and attack their nodes, or I mean their clients. So some examples of that were like different XSS attacks, DNS rebinding, CSRF, and timing analysis attacks. I was able to de-anonymize users on I2P, somewhat, ZeroNet, and especially Freenet. There's many different points of security. This is definitely not all of them in an anonymous network, but these are some of the ones that are most important to me. So you want Sybil attack resistance, and for those who aren't really involved in the decentralized space, that basically means you don't want somebody to be able to easily spin up a bunch of nodes and start de-anonymizing people, kind of quite a lot like what the previous talk was about. Something else that no other network that I know of really has is node anonymity. In my opinion, it would be best if it was difficult to tell who exactly was running a node, because exit nodes can get you in trouble, and any kind of node in some countries can get you in trouble just for running it. Obviously, we don't want arbitrary code execution, but it seems some projects don't really do a good job of writing secure code, so we do get quite a few of those. It's important that we have update mechanisms or notifications, because if there's an exploit, then we want to be able to quickly patch it. We want quantum safety, especially when we're using distributed storage, because we have to consider that things are going to be logged very long term. Who knows when we're going to have quantum computers capable of cracking encryption at mass scale, though. For storage, we also want plausible deniability. So we want to be able to say, well, I didn't make that. It's just always there. If anyone's used Veracrypt, it has like a hidden like container in it that's indistinguishable from random data. So it would be helpful if in a distributed network we had some plausible deniability. And then we want forward secrecy. So if our keys are compromised, then we want to We want past sessions to still be secure. And then usability is a very big point. There's a reason why people don't use Tor all the time, and there's a reason why people don't use all the other networks all the time, and it's simply because they have pretty poor usability. They've definitely improved in recent years, but it's not ideal at all. And in some senses, it will never get as easy as plug and play like a normal browser, but we can definitely make lots of improvements. So I think one big thing we could do is improve the install process with these projects. And something that I would like to see is more of like an onboarding process, as like marketing people would call it. And by that, I mean, we should have like a kind of a tour of the software and kind of educate people better on how these networks work. And we want things to be pretty intuitive, but again, that's never going to get 100%. We want things to be cross-platform. So like Freenet, for example, has basically no mobile support. I've noticed that these networks tend to lack good usability on slow or unreliable connections. So that really hurts their usability, and especially in like third world countries. And we want offline messaging. And now what that means is in the context of like a mail or instant messaging application, we want to be able to send messages to people who aren't currently online or won't be online for quite a while. For example, if anyone's used BitMessage, then you would know that you can't send mail to somebody who hasn't been online in quite a while. It like queues up, and you have to like wait for them to come back online and broadcast their key. Another important point was what I call consensual routing. So Tor, for example, does not enlist you to be a node by default, so it has consent on if you want to be a node or not. And in the context of peer-to-peer applications, a lot of peer-to-peer applications tend to expose your IP address, and anybody can kind of connect to you, and like in theory could like perform a denial of service on you. Like in the past, Skype used to use peer-to-peer for video calls, and that led to people getting denial of service and other nasty things. So I believe that everybody should get your consent to be able to connect to you. It should be like in real life, you typically want a good reason to knock on somebody's door. And then I think transport agnosticism and statelessness is important. So what that means is, like, for example, with a blockchain, you have to be completely in sync with the network in order to be secure. Well, that's not very ideal if you have a slow connection or a highly censored connection. So I think that we shouldn't have any like components or like strong consensus. Now it does have its trade-offs. Like definitely there are many applications such as like currency and whatnot that do require state. So it's definitely not applicable to everything. So this does mean that for my purposes, like anything similar to a blockchain is completely terrible, but blockchain is terrible for everything, let's be honest. Well, that's about all of the requirements. So that really bummed me out when I realized that there was no anonymity network that really joined the best of two worlds of having both good low latency connections for things that need to be fast and high latency connections for things that need to be ultra private, and no storage that's available. There's nothing that combines all that, and so that makes me about as sad as Elliot in that picture. Well, to address all this, I decided I was going to have to make my own, because it didn't seem to make much sense to start basically completely reworking other networks. So I called it Onionr, which means onion relay, but it's still open to interpretation what exactly that means or how to pronounce it. It's a really big work in progress. I haven't released it yet. I'm gonna start making like bundles available, but it's not ready for like real world use yet. So if encourage everybody when you get some time to check it out, but don't use it for anything in the real world other than just playing with it. I've really tried to keep my design with the protocol and the interface fairly simple. I definitely have ways to go on the interface, but the design is very simple. I have a very simple storage format that I use to distribute data across the network. I use proof of work to prevent spam. The exact details are kind of don't have time for this talk, but I'm working on like other mechanisms as well, like web of trust and proof of memory as well. My distribution algorithm and concept is very loosely based on bit message, although I use significantly different cryptography. Now I've separated nodes from users, so everybody is a node by default, but I require consent to store plain text data, and I have the network overlaid on top of Tor and I2P, so there's multiple layers of protection. So if my distribution algorithm is too vulnerable, then you'll at least have the fallback to Tor and I2P, which, as we learned from the previous speaker, are not perfect either. But at least this way, we have multiple layers of protection. So I've used my lessons learned from both using a little bit developing and pen testing other networks. I've strongly improved my web securities based on vulnerabilities I found in other networks. So DNS rebinding and general access to your local software. I take advantage of both latency types via the storage mechanism and via a tunnel system that we'll get to in a second. And I have a well-defined user ID format, so anybody can easily build. Well, I say easily, but I mean more easily than, say, like on Tor or something, can easily build a relatively safe service on top of it, and either distribute it as a plugin or just as a site. Now, I have this ephemeral service tunnel concept where I use the distributed storage mechanism in my network to establish direct tunnels between 2 points. So the best example, like best use case example of this would be for like instant messaging. So if anyone's heard of Ricochet, that was like an instant messenger for Tor. It's similar to that, but it supports multiple devices, and it's very spam resistant. So like if there was a site hosted via this concept, then it would be very hard to perform a denial of service on the site. And basically how it works is it creates anonymous tunnels, like using Onionr addresses, and regenerates them after every connection is over. And it uses the user IDs to authenticate these connections and like verify that they're that the tunnel addresses are correct. And I believe configuration should be easy. So it's a work in progress, but this is a screenshot of my onboarding page. So I kind of have a short survey that people can like enter in their questions, and like at the top, you know, I have like a sort of a threat modeling question. It's not complete. I need to add more available options, but you know, somebody would finish the survey and it would automatically generate appropriate configuration that they of course could then manually modify, or you could just skip the survey if you're like a power user who just has their config files. Here's a quick example of a screenshot of one of the included services, which is a mail system. So it just uses forward secrecy, which and from what I've seen is kind of rare in a distributed network. It's not as strong forward secrecy as you would find in Signal, but you have to make trade-offs when you're working with multiple devices and things don't always arrive in order. Um, as you can see at the top right, there's like a user ID, and that's what it looks like by default. But you can add somebody as a friend that you can see on the menu bar. And after you add somebody as a friend, you then just see their name instead of that. So you only have to work with that key format like ever once per person. The key format is in ed 25519. So I've been trying to use like pretty modern cryptography. Don't really have time to go into that. Here's a QR code and a link at the top. The link and the QR code go to the same thing. I post updates about my project and other things on my two Twitter accounts, my personal account and my account for the project. So I think I have time for like one or two questions.
You probably have time for more. You have 5 minutes before.
Okay, so I have time for more than two questions.
So how do you
For questions, you don't know.
so how do you de-anonymize users on the Tor network? You mentioned it. You didn't explain it.
Well, did you see the previous talk that was in this room? Well, that's a really big topic, and I'm actually not quite as educated about it as the previous researcher who was speaking, but it involves either viewing large portions of the internet or running multiple nodes, like such as like dozens or like even hundreds or more. And over time, you can slowly like de-anonymize somebody.
That answered my question.
Yep. Yep.
How do you deal with the resource consent versus having plausible deniability?
I'm not too sure that I understand your question.
So like if like open Wi-Fi, right? So if I consent to have people use my resources, then I'm making a choice to have people, so it narrows me into a pool of people that can use it. So it weakens my ability to stay anonymous.
Well, the storage network by default already stores encrypted data, so it's in order to make things publicly available, there's also a plain text storage mode, and that's the part that requires consent because it's a little more risky, I guess, and less accepted by people. Did that answer your question? Yep. Yeah, I've researched IPFS a bit. It's pretty interesting, but to me, it's mainly a replacement for BitTorrent rather than as like an anonymity network. It definitely has some applications that could be used for anonymity, but in its state, it's really not designed for privacy at all. I've actually found a few privacy issues with it.